Okay, so if we can start with question 4, it asks us to calculate the length of AC to one decimal place in the trapezium below. Now AC, we actually have to draw in the line AC. And if we draw in the line AC, we can see that the triangle ADC is a right-angled triangle, so we can use Pythagoras. And Pythagoras says that AC squared is equal to AD squared plus DC squared. But we only know one side, 11. We need to find out CD, the length of CD. Now the way we do that is if we draw a line from B to the other side of the trapezium and call that point E, we can see we have a rectangle here, CBED. Now the length BE will be the same as CD. So what we have to do is try and find out the length of BE. Now if we focus on the triangle ABE, we're given the length AB, we can work out the length AE, because if BC is 4 centimetres, then AE is 11 minus 4 centimetres, which is 7 centimetres. So what we can say is that the length BE squared is equal to AB squared minus AE squared. We put in the numbers. AB squared, so that's 16 squared, minus AE, which is 7 squared. 16 squared minus 7 squared, just pop that into the calculator, it's 207. So the length BE squared is 2/7, so the length BE is actually the square root of 207, which is 14.4 centimetres. So that's the first part of the calculation. So we now know that this length BE is 14.4 centimetres. So CD is 14.4 centimetres. Now we can work out the length AC because, let's get my pen working. AC squared is equal to AD squared plus CD squared. AD is 11 centimetres, so that's 11 squared. CD is 14, plus CD is 14.4 squared. So if we pop that into the calculator, that comes to 328. So AC squared is 328, so the length AC is the square root of 328, which is 18.1 centimetres to one decimal place. Question 7 asks us to find the area of the isosceles triangle. Now if you remember, in an isosceles triangle, each of these sides are the same, so I can say that that's 13 centimetres. Now we have to find the area of this triangle, so we know that the area of any triangle is a half of the base, which in this case is 10, this bottom number here, multiplied by the perpendicular height. Now the perpendicular height, we'd need to draw a line up here, and that's the perpendicular height. But that's what we don't know at the minute. But we can use Pythagoras to find out the length of that perpendicular height. So let's label our triangle A, B, C, and I'm going to call this point here D. So what we can say is that AC squared is equal to AD squared plus DC squared. Now DC squared is the one that we don't know, so we can say that DC squared is equal to AC squared minus AD squared. AC is 13 centimetres, so 13 squared, minus AD is 5 centimetres, because that's just a half of that 10 there, so it's 5 centimetres. So 13 squared minus 5 squared is 144. Put that into the calculator. So DC squared is 144. So DC is the square root of 144, which is 12 centimetres. So now we can work out the area of the triangle. The area is equal to a half of the base, so it's a half of 10, which is the base, times the perpendicular height, which is 12. So put that into the calculator and the area works out to be 60 centimetres squared. Question 8. A circle has a diameter of 11 centimetres. A square has side length of 7 centimetres. Use Pythagoras' theorem to show that the square will fit inside the circle without touching the edge of the circle. So basically, what you've got to do is find the length of the diagonal of the square and show that that is less than 11 centimetres, because the diagonal of the square will be the diameter of the circle. Whoops, terrible drawing. Okay, so I'm going to, just for ease to help me explain to you, I'm going to label the square A, B, C and D. Now, we know each of the sides of the square is 7. What we don't know is what the length of CB is, so we're going to work that out. And we need to show again that's less than 11 centimetres. So CB squared is equal to AC squared plus AB squared. That's just Pythagoras. So AC squared is 7 squared, AB squared is 7 squared. So 49 plus 49 is 98. So CB is 90, CB squared is 98. So CB is the square root of 98, which is 9.9. Now 9.9 is the length of this CB, and it's less than 11 centimetres, so we've shown that it will fit, that square will fit inside the circle. Now question 12, it says, gives us a triangle and asks us to find out the length BC. Give our answer to 3 significant figures. Well, in this triangle we're given an angle and we're given a side, so straight away I can see it's trigonometry. So before I even start, I write down my little trigonometry reminder, which is SOHCAHTOA. What that means, of course, is the sine of the angle is the opposite over the hypotenuse, the cos is the adjacent over the hypotenuse, and the tan is the opposite over the adjacent. So then I'm going to label my sides in this triangle, remembering that they want me to find out the length of the side BC. So that's this side. This side is the hypotenuse. AC is the opposite because it's opposite the angle of 71, and AB is the adjacent because that's adjacent to the angle. Now thinking about the question, it wants me to find BC, which is the hypotenuse. It's given me the adjacent side length. So I need to pick a trigonometry ratio that involves the hypotenuse and the adjacent. And the only one that involves the hypotenuse and the adjacent is the cos. So remembering our pyramid, cos is equal to adjacent over hypotenuse. So we can say that the cos of 71 is equal to the adjacent, which is 6.3, over the hypotenuse, which is BC. Now that BC is what we don't know, so I'll rearrange this equation. BC is equal to 6.3 divided by the cos of 71, and if I put that into my calculator, the answer is 19.35 something 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 something. But I want my answer to correct 3 significant figures, so I need to just have 3 digits in the answer, so I'm going to chop off that bit. So because that's a 5, I'll round the 3 up to a 4, so the answer is 19.4 centimetres, and that's the answer to that question. So here we have question 13. It asks us to find the size of angle YZX. So I'm just going to identify that. YZX is this angle here, because it's bounded by Y, Z and X. And if it asks us to find the size of that angle, and we're asked to give our answer to 3 significant figures. Now again, it's trigonometry because it wants us to find an angle and gives us some sides. So before I even start, I'm going to write down the SOHCAHTOA, which is my reminder of the trigonomical ratios. Then I'm going to label the sides of my triangle. Here's the angle. So this side is the opposite, XY is the opposite side, ZX is the adjacent side, and ZY is the hypotenuse. So looking at my triangle, it's given me the hypotenuse and it's given me the opposite side. So the ratio I'm going to use is the one with hypotenuse and opposite in it, so it's the sine ratio. So I know that the sine of the angle, which is YZX, is equal to the opposite over the hypotenuse. The opposite is 7.5 over the hypotenuse, which is 22.3. Put that into my calculator, and it comes out to 0.336. So I know that the sine of the angle YZX is 0.36. So what I have to put into my calculator then is arcsine, or sine to the -1 of 0.336 to find the angle, and that gives me the angle of 19.68 so degrees. It wants 3 significant figures, so I'm going to round it up to 19.7 degrees. So this angle is 19.7 degrees. So here we have question 17. Question 17 tells us that the line AB is 6 centimetres, AC is 12 centimetres. Calculate CD. So it wants us to calculate this line here, CD, and it asks us to give our answers to 3 significant figures. Now looking at this here, we've got 2 right-angled triangles pushed against each other. One of the right-angled triangles ABC were given 2 sides, and in the other right-angled triangle we're given an angle. Now it wants us to calculate the side of CD, so that's a length. So I would say anything we do with this triangle here, BCD, would be trigonometry, but initially we need to find out the length of CB to enable us to use a trigonomical ratio on that second triangle. Now in order to find out the length of CB, I'm going to use this triangle here, and because I'm not given any angles, I can see it's Pythagoras. So what I can see is that AC squared is equal to CB squared, CB squared plus BA squared. Now AC is 12, so 12 squared is equal to CB, which is what we don't know, CB squared plus BA, which is 6 centimetres, so that's 6 squared. Now I'm going to rearrange that equation. So 12 squared minus 6 squared is equal to CB squared. So if I put all that into my calculator, I can see that CB actually turns out to be 10.4 centimetres. Okay, so we worked out CB is 10.4 centimetres. Now, in order to calculate the length DC, as I said, we're going to use trigonometry. So straight away I write down my trigonomical ratios, SOHCAHTOA. I know I want to find out the length of the hypotenuse, so that I'm going to label the sides. That's the hypotenuse. There's the angle of 55, so CB is the opposite angle and DB is the adjacent angle. Now it's given me the opposite angle, 10.2, and it wants me to find out the the hypotenuse. So it's given me the opposite, wants me to find out the hypotenuse. So the ratio I'm going to use has to have the opposite and the hypotenuse in, and so that's sine. So what I can say is that the sine of 55 degrees is equal to the opposite over the hypotenuse. The opposite is 10.2. The hypotenuse, well, we don't know that yet. It's DC or CD. So I can say that DC is equal to 10.2 divided by the sine of 55 degrees. And if we plug that into the calculator, it actually works out to be 12.7 centimetres, correct to 3 significant figures. And that's the answer to question 17.